In this video, I'm going to cover chapter 4.2 addition rule and multiplication rule. So we're talking about the probability, right? So the last time we learned about the concept of probability, there were three approaches, right? Relative frequency approaches and the classical approaches and then subjective approach. But most of cases we use a classical probability. Okay, so now and then let's see addition rule and multiplication rule. So you see the lecture slide. In this section, we present the addition rule as the tool for finding probability that A or B, and the probability A and B will later. So which is the probability that either event A occur or event B occurs, or they both occur as the single outcomes of a procedure. So the word or in addition rule is associated with the addition of probability. Okay, so or means the A uh, kind of A union B, union the B. Okay, so it means that probably that we event A or B, either A or B or both occurs. So and then that is associated with the addition rule. We have to apply the addition rule, and then the contrarily A and B we use a multiplication rule. A and B is that both event A and B occur at the same time. Okay, so now and then compound event is any event combining two or more simple events. Yeah, so now then A or B, A and B could be compound events, right? So addition rule. So PA or B means that P probability that in a single trial event A occurs or event B occurs or they both occurs. So now then, here's a formula for the addition rule. Probability A or B is going to be P of A plus probability A, okay, plus probability B minus probability that A and B. Why we have subtracted probability A and B? Because you see that the give me a second. Because if let's say this box represent the sample space, normally we use capital letter S, okay. So now then, let's say the this region represent the event A. Okay, so event A, and let's say this is that other the circle represent event B. Okay, so there's the outcomes right here. Okay, but you can see that some of them, I mean, the A in a section B, which is this part, see that part, all the outcomes belong to that region, means that event belong to event A and they belong to event B, right? So we want to find out so the when you find the probability A and B, okay, then we find out all the outcomes in that area, in that region, okay, divided by, so let's say, for example, let's say here is, I mean, uh, number of outcomes in this region, okay, in that region divided by total number of outcomes, right? So total number of outcomes in sample space S. Okay. So now then what? Then but we're talking about probability A or B, right? B A or B. So then P A or B, this is gonna be means that what we'll find out all the outcomes belong to either A or B, right? So A or B here then can be calculated by PA plus PB. Let's say okay this. But see here, when you find the probability A, we're gonna count all the outcomes, not only here, but also in that region, right? Okay. So now then, when you find the probability B, we're gonna count not only count the all the outcomes, not only this region, but also this one. So it means that we're gonna we yeah, that cause that what we count the outcomes in that area twice. So that's why we subtracted probability A and B. Okay. You see that the why we subtract this one, because we count the outcomes in that region twice when you calculate P of A and P of B. That's what we subtract the P of A and B. So keep in mind that addition rule. So now, so see, yeah, so intuitive addition rule. So keep in mind is to find the P of A or B, add the number of ways event A can occur and the number of ways event B can occur, but add in such a way that every outcome is accounted only once. That's why we subtract the probability of A and B. Okay. So now then, let's see examples. So we saw that table the last time, right? Let's see. Here's a question. So if one of the subject is randomly selected, yeah. Otherwise, we cannot use classical approach. Okay. So now then, find the probability that the person used drug or had a positive test result. So you person used drug. Let's say this is event A, and then had a positive test result. That's let's say that's event B. Okay. So now then, A is what? A. I mean, let me use A. The set of what? Person used drug, and then B is this set all the outcomes. I mean, persons had a positive test result. Now let's figure out the number of outcomes in event A. Normally use a lowercase letter n. Okay, A. It means that that's the number of outcomes in event A. It's gonna be um, the what? How many person use drug? 50, right? 44 plus 6, right? Which is 50. Then what's the number of outcomes in event B? So how many person had a positive test result? 44 plus 94, right? 44 plus 90, which is 134, right? Okay. So now we're gonna find out probably A or B, right? That's what you see. Because find the probability that the person uses drug A, I mean, or had a positive test result B, right? That is equal to, and let me use a addition rule. This is the probability of A plus probability of B minus probability of A or B, right? Okay. Now let's find the probability A. P of A gonna be what? 50 over 1000, right? Where 1000 comes from? Total number of persons received a screen test. Okay, so plus P of B, probably the person had a positive test result is what? The 134 divided by 1000, right? Okay, the minus. Now next one, P A or B. We need to figure out that to figure out P of A or B, we need to figure out number of outcomes belong to both event A and B, which is the what? 44, right? This person, 44 person, this person used drug and received positive test result, had a positive result, test result, right? So that's going to be 44 divided 1000. Okay. Now this is equal to, see that all three fractions have the same denominator. So then this is going to be what? 50 plus 134 minus 44 divided by 1000. Okay, you see that? So now then, so I got, this is a 0.14. Okay, so that's a probability of A or B. Okay, so now next question, find the probability the person does not use drug or had a positive test result. So now A is what? Event A is all the outcomes and persons does not use drug. Okay, so no, it says just no drug. Okay, event B is to say all the outcomes, had a positive test result. So it says this is positive test result. Okay. Okay, so now then this is then what number of outcomes in event A gonna be what the 90 plus 86, right? 90 plus 860. That's gonna be 950. Okay, and then number of outcomes in a sample event B gonna be positive test result is 104, right? Okay, so now probability A or B that is equal to what P of A plus P of B minus P of A or B, A and B, right? Yeah, this should be and, right? Sorry, A and B. So now that is equal to 950 divided by 1000. Oops. And then plus 134. Okay. Divided by what? Give me a second. 1000. Yeah, 1000 minus. Okay, so how many person uh doesn't use drug but had positive test result? 90, right? So these persons um, had a positive test result even though they didn't use drug, right? So it's going to be 90, right? Should be 90 divided by 1000. Okay, that's going to be 950 plus 134 minus 90, and then divided by 1000. Okay, so we got the 0.994. Okay, 0.994. So now, next question: find the probability that a person does not use drug or had negative test result. And then find the next question. And then the next question: find the probability that person used drug or had a negative test result. So let's see. This similar to this. Okay. So now A gonna be. Give me a second. Yeah, I just decompute all um compute the probability. I figure out the probability A or B for each two problems. Okay. So the uh the solution is really similar to the previous two problems. Okay, so this one, find the probability the person does not use drug or had a negative test result. Then we find out the P of A, which is, or you can say just a number of outcomes in event A, which is 950, and the number of outcomes in event B had negative test result 866, and then we find out number of person who had negative test result and used drug, but didn't use drug, and didn't use drug. So 6%, right? 6%, not 6%, 860. This person um, didn't use drug and had a negative test result. So we subtract that numbers. Okay. So from the number of outcomes event A and then plus number of outcomes event B. Again, divided by 1000, not 100. Okay. Okay. So now the similarly we can figure out the we can calculate the probability A or B, probability that person used drug or had a negative test result. Okay. So now next one is A or and B are disjoint or mutually exclusive. It means that two event don't have common outcomes. Okay. So it means that so that since they don't have common outcomes, it means that they cannot occur at the same time. Okay, so it means that probably A and B must be equal 0. Okay, so keep in mind this: two events are mutually exclusive or disjoint means that there is no common outcome between two events A and B. So the probability that A and B must be equal 0. Okay, so example, using the table above, find the probability that someone got a positive or a negative test result. Okay, so now let's say A is the positive test result. Okay, got positive, and then let's say B is a negative test result. Let's say all the outcome person had negative test result. Okay, then what? Then probability A or B using the addition rule, this is going to be P of A plus P of B, right? Minus, and then P of A and B. Okay, but you know that what does that mean? Probability A and B. Probability that a person had the positive test result and negative test result. That doesn't make sense. Okay, so two events A and B. In this example, two events A and B must be mutually exclusive. So it means that probability P of A and B must be 0. So this is equal to what? P of A just plus P of B. Okay, so which is the P of A gonna be what? 134 over 1000. P of B gonna be 866 over 1000. So this is gonna be 134 divided by 1000 plus 866 divided by 1000. Okay, so which is what? 1, right? 1. So because people must people must have what? Either positive result, test result, or negative test result, right? So only two outcomes we expect. So the probability A or B must be 1. Okay. So now then the so keep in mind this disjoint mutually exclusive and the addition rule. Okay. And then the multiplication rule. So I think this should be the complementary. That one must be in the chapter 4.3, but multiplication rule belong to the chapter 4.2. So let me cover this. excuse me. So multiplication rule is this P A and B. Multiplication rule is about the probability of A and B. Okay. So that is this. Give me a second. P of A and B mean, means that the event A that is nothing but probability the event A occur in a first trial and event B occur in a second trial. So now then we can say like this. Okay, so now then probability A and B. Okay, so then we can first we gonna find a P of A, probability A occurred first time, times, you see that here, P of B bar, vertical bar A, that's actually conditional probability. We're gonna study conditional probability in chapter 4.3, okay? But what does that mean? That means, that symbol means the probability that B occurred, given that probability that event A is already occurred, okay? So in that probability P B bar A means that event A is already occurred, assuming that we're gonna find out probability that event B is occurred. Okay. So the P of B bar A represents the probability of event B occurring after it is assumed that event A has already occurred. Okay. So now then, that's the multiplication rule. So key mind is this one: P of A and B equals P of A times P of B bar A. Nowadays, you see that the what? Sometimes it's easy to figure out the conditional probability, but sometimes it's not. Okay, so we need to study conditional probability in chapter 4.3. Okay, so let me continue to look at the multiplication rule the next time. Okay, let me stop here.